Welcome friends, my name is Sagar Deshmukh. Today in this video we'll start the numerical on design of combined trapezoidal footing. We'll start with the problem statement. Design a combined footing for two columns which are 3.6 meter center to center apart, carrying load of 850 kN and 11 1100 kilonewton at service respectively. The size of columns are 350 by 350 and 450 by 450 mm. Take SBC of soil as 180 kilonewton per meter square. Use M20 grade of concrete and Fe415 grade of steel. Length of footing is the condition which is given for this numerical is the length of footing is restricted to 5.5 meter. Sketch the reinforcement details too. Okay, so this is the numerical on combined footing. Now in the previous video we have discussed that how to analyze whether the design of this footing should be carried out as per design of rectangular combined footing or as per the trapezoidal combined footing. So let's see what type of footing can be used here. First of all, we'll check whether the loading given for two columns is same or not. We can see that here we have 850 kilonewton of load and the loading on other column is 1100 kilonewton, that is 1100. It means this column is carrying lesser load than this one. So for trapezoidal footing the first condition is satisfied. The second condition is that if the restriction of length is given, then we will go for trapezoidal footing. If the restriction of width is given, we will go for rectangular footing. So it is given that the length of footing is restricted to 5.5 meter. So we'll go for providing which type of footing then? Trapezoidal combined footing. Okay, as two columns are having unequal load on them and the length of footing is restricted, so that's why both of the clues are denoting towards the trapezoidal means we should design the combined footing as trapezoidal footing. Okay, so in order to design, first step is to write the given data. So we'll write all the given data. The center to center distance between two columns is given, that is 3.6 meter. Load on column A is 850 kilonewton. Load on column B is 110 kilonewton. Size of column A is 350 by 350 mm. Size of B is 450 mm by 450 mm. Length of footing is restricted to 5.5 meter. Next, the characteristic strength of concrete is 20 Newton per mm square and that of steel is 415. Yield strength is 415 Newton per mm square. Okay, so we have written all the given data. Now what steps we are following, we'll write these steps in short. First of all, we know that we have to calculate the area of footing. After calculating area of footing, we'll try to find out the dimensions of footing too in this step. After that, we'll go for determining the upward soil pressure. After that, we'll determine the bending moment at various points in the footing, and by equating this bending moment with limiting moment, we'll calculate trial depth. After calculating trial depth, we'll check this trial depth for one way and two way shear at different position. Okay, after getting this conditions or the checks of one way shear and two way shear satisfied, we'll move towards the provision of reinforcement. So we'll provide reinforcement according to the moment we have got at that point. We'll also check this reinforcement whether it is greater than the minimum reinforcement or not. If it is not greater than minimum reinforcement, then we'll provide this as a reinforcement at any section. So after providing this longitudinal reinforcement, we'll design all the details like spacing, the shear reinforcement for main reinforcement, and we'll also design transverse reinforcement. Okay, after designing transverse reinforcement, we'll sketch out the details of the reinforcement in the last step. So this is how we are going to solve this problem. As we have discussed earlier that it is very important to know all the steps which are involved in the design of footing. So that's why I have revised these steps. So let's move towards the calculation of area of footing in the step 1. So in order to calculate the area, first of all we'll calculate the total load. To calculate the total load, we have to calculate load through column. So we have load of 850 kilonewton on one column plus the load on other column is 11000. So it will be 1950 kilonewton. So this is the load, total load on two columns. Now self weight of footing. So here this is step 1. Second, we'll calculate self weight of footing. As we know that we are going to assume the self weight of footing as 10% of load on column. So self weight of footing will be equal to 10 divided by 100 into 1950. So it will be 195 kilonewton. You can calculate this. So after adding these two, that is load on column and self weight of footing, will get total load. Total load will be equal to 1950 kilonewton plus 195 kilonewton. So here we can write 4 will be the second place, and so 9 plus 1 10 and that one 11, so it will be 2145. Correct if I am wrong. Okay, so this is 2145 according to my calculation. Please cross check that. After this, we'll calculate the area of footing. Now we have got total load, so we'll calculate area of footing. We know that for calculating area of footing, right here. So formula is total load divided by SBC, shape bearing capacity of soil. So we'll convert this load into Newton. It is 2145 into 10 raised to 3 divided by SBC of soil is 180. Okay, so it will be 17.87 mm. It is meter square, I think. Okay, so now we'll calculate the other dimensions of footing. we know that in the trapezoidal footing, the two sides which are in front are parallel to each other, and in this length is constant everywhere, but the length is constant, but this side width is not constant, or width on two sides is different. Now, if suppose this is column A and this is column B, we know that the distance between these two columns is given, and it is 1.6, I think. It is 3.6. Okay, so let's check how much will be this projection of footing on two sides of the column. So in order to find out that projection, what we will do, we'll divide this projection in the equal parts. So 5.5 minus 3.6, the rest of projection we are dividing in two parts, so it will be 0.95 meter. So this will be 0.95 meter, and this is again 0.95 meter. Okay, now we'll find out the position of CG from column A. So CG will be, of course, it will be CG of loading. Okay, from column A. Position of CG of loading from column A. So in order to find out the position from column A, we have to take the load on column B into the distance between column A and B, that is 3.6, divided by total load on two columns, that is 1950. Okay, so it is 1100 into 3.6 divided by 1950. So it will be 2.03 meter. I have calculated this already. We'll denote this position of CG of loading from center of column A as X bar. Okay, now we know that for this footing, the CG of loading due to loads on column or two column must coincide with CG of footing, or CG of area of footing. Okay, so in order to satisfy this condition, the XA, that is projection on the projection of footing on the side of column A, plus X bar should be equal to the CG of footing, which can be calculated by A plus 2B divided by A plus B into L by 3. This is the formula of CG, calculation of CG of area, trapezoidal area. So if you simplify this, and this A and B, let me tell you, this A and B are nothing but the widths of the footing. Okay, so if you simplify this and if you calculate the equation, so I'll write the final equation directly. A plus 2B will be equal to 10.66 meter. This will be the equation from this. Okay, the second equation we can calculate, which will be from the area of footing. We know that we have calculated the area of footing as 17.87 meter square. Okay, and we also know that for trapezoidal footing, the area of footing is calculated by using the formula as length into the average of other two widths. Okay, so from this, length is 5.5 meter, so we can write A plus B will be equal to 17.87 into 2 divided by 5.5. So this will be the second equation. If you solve this two equation, you will find out the value of A and B. I will directly write the value of A and B. A is 2.42 meter, whereas B is 4.08 meter. Okay, you just cross check this whether it is right or not. So till now we have solved the numerical till the calculation of dimension of footing. In the next step, after calculating the dimension of footing, we will check the upward soil pressure in the step 2. So we will calculate upward soil pressure and we will check whether it is in the range of SBC or not. So upward soil pressure P will be equal to column load, it will be factored load of column divided by the area of footing. Okay, so column load will be, I am directly writing the factored load 1950, okay, divided by area of footing is how much it is according to our calculation. I think it is 17.875. Okay, if you calculate this, you will get 163.63 kilonewton per meter square. Now you can see that this P is less than SBC of soil, SBC, that is soil bearing capacity, as it is 163.63 and this is 180 Newton per mm square, kilonewton per meter square, sorry. So the same condition which we wanted is we got. Hence, as SBC is more, this footing is safe or hence okay. So in the next step, we'll calculate the moment, then we'll also see the calculation of shear force. Now we will stop till this point in this video. We'll see the next part of design of trapezoidal footing in the coming video. Thank you for watching this video. Till now we have discussed the two steps. Please try to solve the third step if you can solve yourself at home. If you can't solve this, we will discuss it in the next video, but I expect that you have to try this, because once you try all the steps of design and you'll remember all the steps, it will be very easy for you to understand the design of footing or design of any structure. So you should try at your own and you should know what are the steps of design and why we are performing these steps. What if the particular changes are made in the steps, means what is going to happen if we make some changes in the design, which is better change, which is not good for the design. So be ready with the third and fourth step in the next video. We'll check whether you have solved in right way or not. Till then, thank you for watching this video.